Hi everyone, my name is Vijay Bharati Anne, and today I'm joined with my team members to give a presentation on analysis on New York Police Department arrest data. So we are three in our team. So team number one is Mr. Akshit Rao Singham, team number two is Mr. Avinash Bodla, and team number three is myself. So getting into the presentation, uh, the table of contents are introduction, literature review, methodology of data preparation, exploratory data analysis, and conclusion. So, coming to the first slide about the introduction, New York Police Data is the largest police department in the United States. It also utilizes data-driven techniques for crime prevention, and it lists various tools and technologies used for crime prevention. And coming to the next slide is all about the drawbacks of AI tools. Drawbacks and concerns associated with various AI tools and technologies used by police departments for crime prevention are facial recognition systems, video analytics, social media monitoring, criminal group databases, predictive policing, cell site simulators, automated license plate readers, domain awareness systems, drones, body cameras. And these points highlight the ethical, privacy, and bias related issues associated with the use of AI tools and technologies in law enforcement. It's important to consider these drawbacks when discussing the implications of AI based crime prevention methods. And next slide, please, is all about analyzing NYPD arrest data and its significance. So it provides valuable insights into crime patterns, law enforcement strategies, and demographics of arrest. Opportunities for creating better policies, protocols, and resource management. And also, it identifies areas for correlation or policy initiatives and informs public policies. It recognizes limitations in data accuracy and partial view of criminal activity. It highlights the significance of NYPD arrest data in identifying discrimination and suggesting policy improvements and emphasizes the need to improve current AI tools for crime prevention and dispense justice effectively. Next slide, please. Chapter 2 is all about the literature review. Uh, the literature review, the NYPD is established in 1845 and is responsible for various public safety roles in New York City and achieved significant crime reductions over the years. The policy concerns regarding AI technologies used by NYPD are facial recognition, privacy concerns, video analytics, and potential racial biases, and also issues with gang databases and predictive policing methods. Studies on crime predictions using machine learning given by Lavanya Hitesh Kumar Reddy, Lawrence Clendon, Wheeler, Inglung, Saftel have conducted research in this area. Criticisms of predictive models for arrest are models show bias towards minority communities, concerns about fairness and equity in law enforcement. Racial disparities in drug arrest, domain awareness systems of the NYPD, comparison of machine learning algorithms for crime prediction, evaluating various algorithms such as random forest, K nearest neighbors, long short-term memory, gated recurrent unit, convolutional neural network for crime predictions. Uh, and next slide will be continued by my friend.
As a part of data analysis, data cleaning is the crucial step where we can identify and correct the errors or to identify about the inconsistency of the data to ensure the accuracy and reliability. This includes in the handling of the missing values, the duplicate values, and correcting the data formats and dealing with the outliers. Uh, as we employed the Excel for the initial data viewing and the simple analysis, and later proceeded to do the Python libraries has been used for the detailed analysis like the Pandas, Seaborn, Matplotlib, and Skilllearn. And this dataset has been collected from the NPC open data. And this includes the crime type, location, time, and the geographical locations. They are the key variables which In these data sets are the arrest key, arrest date, jurisdiction, age group, sex, race. As a part of it, the initial cleaning, we have removed the null values from the columns like the lockat CD and the CYCD. Later on, the removed null values from the specified columns to ensure it has the data integrity and data integrity. This dataset consists of the 2 lakhs arrests and the criminal records recorded in 2019. As we can see with the analysis, like the data has been consistently increasing in the crime over the time. And the geographical data, it includes the latitude, longitudinal data of the arrest. Next slide, please. And these are the key fields of the data set where we can have the field name and the description has been mentioned on the screen. Can you please proceed to the next slide? Uh, as a part of the analysis, we can see that the top offense from the NYPD data is the misdemeanor and the felony. The Brooklyn records the highest number of arrests, followed by the similar counts in the Queen, Manhattan, and the Bronx. The major crimes in the NYC includes the petty larceny, felony assault, and assault-related offences. Below are the various bar plots which has been provided for the detailed analysis purpose. And here is the comparison across the various places and the various crime types. Please proceed with the next slide. And as a part of the analysis, we came up to conclusion like the individual aged between the 18 to 44 are mainly involved in the assaults, while minors are more likely to be involved in the robberies. The males are the predominant over the females, and the females are more frequently arrested for the assault and the related offenses, followed by patent latency. Here is the various bar charts for the gender categories about the number of arrests has been recorded for the particular year. And we are coming to the more graphs, like we have plotted the bar graphs between the various columns, like the bivalent analysis about based on the age groups and the arrest types. Can you please proceed? Here is about the correlation matrix between the various columns. As we can see, the correlation matrix is identifying the relationship between those columns and their dependencies. Here we can see the heat map, the arrest key and the maximum correlation matrix we can see between the latitude and the y coordinate CD. It's about the 0.65. The later on, we can see not much relationship between those columns. The maximum we can see the one between those columns itself. Can you please proceed? Here is the displaying the distribution of the various assets over the period of time, the based on the year, month, and the date. As we can see, the year 2023, the arrest has been recorded nearly 1,70,000. And when compared to the month basis, we can see maximum has been recorded in the month of May. And below is the graph for the based on the daily basis. And next we have segregated about in order to have the clear view of the analysis, then we have segregated based on the age group with the number of cases and based on the race and also committed based on the males of each race. Can you please provide that? Yeah. Here is the graph which is based on the number of cases on the age gender level, and one more graph where we are defining about number of crimes committed in each borough by month. And the next slide will be explained by the Akshay.
Hi, and the dataset provides insights into the crime patterns, temporal trends, geographical distributions, and demographic profiles of perpetrators. Analysis of arrest frequency helps identify crime hotspots and emerging trends. Demographic analysis reveals characteristics of individuals involved in criminal activities, guiding in targeted intervention strategies. Predictive modeling forecasts for future crime trends and identifies high risk individuals or areas. The New York Police Department arrest data supports evidence based decision making, resource allocation, and strategies to enhance public safety in New York City. And the EDA is shown in by the arrest counts by date and arrest by borough and arrest by race, and the top 20 offenses type and arrest by age group. Here we can see the high rate of crime is on Wednesday, and in the month wise, May is the highest rate of crime. And coming to the week, first week of the month, they are seeing the high rate of crime. And here you can see the top five crimes throughout the year: assaultery and related offenses, petty larceny and felony assault, dangerous drugs, and miscellaneous penal law. The hypothesis one is objective. Determine if there is a significant difference in arrest rates among racial groups. And the test used here is Chi-square test. And the result we got from that is no significant difference found among racial groups. And the p-value for this one is 0.498. The explanation. Chi-square statistic measures deviations from expected frequencies in categorical data, with the p-value indicating the probability of observing such a statistic assuming the null hypothesis is true. And in the second case, investigate if black race group members are more likely to be arrested. And here the test used is jet statistic test. And the result we got is significant difference found in arrest rates between black and non-black individuals. Here is p-value 1.58. And the explanation is Z statistic measures deviation of observed proportion from expected proportion, with the p-value indicating the probability of obtaining such a statistic assuming the null hypothesis is true. And the project analysis here. Data pre-processing. Clean the dataset, handle missing values, outliers, and inconsistencies. Encode categorical variables. Convert categorical variables into numerical format. Define time period for recidivism. Determine the time window for defining recidivism. Feature engineering. Create features from arrest history. Aggregate information about prior arrest. Engineer demographic features. Extract additional predictive information from the demographic variables. And the model selection. Here we need to choose the appropriate machine learning algorithms for binary classification and consider ensemble methods or stacking techniques for improved performances. In the model training, here we need to train the selected model on the training dataset. Use the techniques like cross validation to tune the hyperparameters and prevent overfitting. Model evaluation. Evaluate the trained model's performance on the testing dataset using various metrics. Challenges with the data. Ensure data quality and completeness. Address bias and fairness concerns in law enforcement practices reflected in the dataset. Here, the analysis approaches are like crime prediction, demographic analysis of arrest, crime classification, and predictive policing. And on the second case, bias detection, arrest time prediction, demographic disparities in arrest, and recidivism prediction. And the logistic regression is a statistical analysis tool used for forecasting a binary outcome based on the dependence between variables and prior observations. It establishes the relationship between a binary dependent variable and one or more independent variables, which can be nominal, ordinal, continuous, or discrete, commonly employed in predicting discrete yes or no variables. And the random forest is a machine learning technique comprised of decision tree models primarily used for classification and regression tasks. Creates multiple decision trees during training, which where each tree is provided with a subset of data and features to learn from. Random forest prevents overfitting of decision trees and performs well in various domains such as medical, financial, and marketing. And the handling the missing values, process dropping null values from columns like LAS, law underscore cat underscore CD or KYCD or PDCD to ensure the data integrity. And the result we got from this is after handling missing values, further analysis and modeling are conducted. Logistic regression model. With performances, we got the training accuracy score is 0.5632 and the testing accuracy is 0.55. Interpretation, the model shows moderate accuracy in both training and testing phases. And in the random forest classifier, the performances, the accuracy score is approximately 0.8813. And for training, we got 0.6928. And for this is for testing. And the observation is overfitting is indicated as the training accuracy exceeds the testing accuracy, highlighting the need for the model refinement. An XGBoost classifier achieved training accuracy of 0.7338 and testing accuracy 0.6893. In the best model utilized XGBoost classifier with tuned hyperparameters, training accuracy 0.8592 and the testing accuracy 0.6902, indicating good generalization. Feature importance. Plot displays relative importance of features in predictions. Model comparison, line plot comparison, training and testing scores of logistic regression, random forest, and XGBoost models, indicating performances on training and testing data. The predictive analysis is random forest classifier used to predict likelihood of crime accuracy based on selected features achieving 43.56% of accuracy, and XGBoost identified as the best model for predicting hit and run incidents. In this EDA, we can see the feature importance and F score and the features like offense description and age group, preparation sex, loss, cat CD, and arrest borrow. And you can see the arrest key, frequent, and the day, month, day of the week, and so on with the feature importances. And in here you can see the training and testing accuracies of different models with the logistic, random forest, and XGBoost. And the conclusion will be given by my teammate Karthik.
Yeah, so the NYPD datasets gives insights in law enforcement and crime patterns. Challenges include data quality issues and potential biases. Machine learning for crime forecasting utilizes weather and historical data for effective public safety strategies, offers enhanced crime prediction capabilities. Lavanya's research findings demonstrates the link between climate indicators and criminal offenses, utilizing statistical methods and machine learning in NYC. Comparative studies highlight the effectiveness of random forest in long-term crime prediction over traditional methods. Benefits of data-driven approaches enhances resource allocations and inform public security initiatives, and also improve decision-making processes within law enforcement. Some ethical consideration address bias and privacy breaches associated with AI in law enforcement, emphasizing the importance of transparent policies and ongoing monitoring. And key takeaways are the NYPD dataset and machine learning technologies offer significant potential for improving public safety. Continued research and development are essential for addressing challenges and maximizing the benefits of data driven approaches in law enforcement. Ethical considerations must be prioritized to ensure fairness, transparency, and accountability in use of AI technologies. And we are from group number 6. Thank you.